Hello everyone. Sorry I'm not there today. Just needed a little rest. I should be back tomorrow. We are going into our unit on linear functions. So the first thing we need to talk about is rate of change and slope. So the rate of change shows the relationship between two changing quantities. The rate of change is also called the slope of the line. Rate of change is the change in the dependent variable over the change in the independent variable. Remember, the independent variable is the one that can't be told what to do. Time is always independent. Anything you have to do with minutes, days, seconds, hours, years, whatever, if it's time, it's independent. Okay? So we're going to take a minute and watch this video. Well, maybe 2 minutes. Okay, let's see if we can get it here.
In this episode of 2-Minute Math, I will discuss what rate of change is and how it is both essential and practical in everyday life. In order to learn rate of change, you must understand two important facts: how the value of something goes upward with respect to the value of something going outward. What does that mean? In math, the rate of change is described as the rise over the run, which is also the definition of slope. Basically, the change in the y value, the rise, which only moves vertically, over the change in x value, the run, which only moves horizontally, written as a fraction. This fraction will result in what we call our rate of change, or slope. As a side note, these two triangles are the Greek letters delta that mean change in. You will see me use these throughout the duration of this video. To visually grasp the concept of rate of change, let's use the popular social media app Snapchat. According to 99 firms, Snapchat users are sending on average 3.5 billion snaps each day, which is an astronomical figure. The rate of change in this case would be 3.5 billion snaps, the rise, or change in y value, over one day, the run, or change in x value. So the fraction would be 3.5 billion over one day. Now, how many snaps would be sent in 10 days? Pause the video and see if...
All right, take a second and see if you can figure out how many snaps would be sent in 10 days. I already forgot the number, but it's on your paper. $3.8 billion in one day. How many in 10 days?
Can figure it out. The answer would be 35 billion over 10 days, written as a fraction. And that is the rate of change. And that is also a lot of snapping. I hope this video helped you understand rate of change and how practical it is. That's going to do it for this episode of 2-Minute Math. If you enjoyed the video or learned anything, leave a like. Be sure to subscribe and hit that notification.
Video on rate of change. I think it makes a lot of sense. So let's keep going here. So here's an example when we're talking about rate of change. It's a marching band example. The table shows the distance a band marches over time. Table is right here. Is the rate of change in the distance with respect to time constant? What does the rate of change represent? So for the rate of change to be constant, we need to do this right here. So we need to calculate how are the x values changing and how are the y values changing. So if you see right here, they got 260 over 1. That means that this is going up 260 feet every time. And this is going up 1. minute every time. So the rate of change is constant, and it equals 260 feet per minute. And the big question here is, do you get the same rate of change if you use tables, if you use rows in the tables that are not right next to each other, that are not consecutive? And the answer is yes. You get the same answer, but it's hiding because you are going to have to simplify your fraction first. Okay? And here's what a graph for that problem would look like. The graph for the marching band problem. The distance between the relationship between time and distance is linear. When data are linear, the rate of change is constant or the same. And that rate of change is called the slope of the line. And here is a whole bunch of different ways to think about what slope is. So slope is the vertical change over the horizontal change, the rise over the run, delta y over delta x. The guy in the video said delta is that triangle, and it means change in. That's like big kid math notation. And I personally really like the notation that uses the arrows to remind you to go up and down first and then left to right. Now we're going to talk about slope. There are 4 different kinds of slope. Okay? A positive slope is going to point off to the right, to the left. Sorry, I know my right and left. No, I don't. That's right. Yeah, that's right. Their wording confused me here. So it goes off to the right, and there's 2 ways to make that slope. With a positive fraction, you can either have a positive over a positive, or you can have a negative over a negative. A line with a negative slope slants downward from left to right. That one goes off to the left on the top. And here, to make a negative fraction as our slope, you just need one way to be positive. So you can go up and left, or you can go down and right. Here's up and left. Here's down and right. Okay. Then there's 2 special kinds of lines. A horizontal line has a slope of 0. When you're doing this math, you're going to get a 0 on top. Let's write that. Ooh, that's too thick. 0 on top. 0 on top, you're going to get a slope of 0, and that is a horizontal line, and it is a y equals something line. Please add all these notes as I do. Okay. All we care about is where that line goes through the y-axis, so it's a y equals line. A line with an undefined slope is vertical. And this is where you get 0 on the bottom. So let's write that. It's 0 on bottom. And all we care about is what x value this goes through. So a vertical line is going to be an x equals line. All right, we're going to watch this video about Slope Dude. Mrs. Gick found him last year, and he is fantastic. So give me a second here to make sure all my buttons are right. We do this, we do that. Get that. We get rid of that. There we go. And then slope dude is here. Slope dude's my favorite. It's a really good way to remember your different kinds of slopes. Here we go.
Professor Dave again. Let's talk about related rates. Professor Dave again. Let's talk about related rates.
Okay, we got 2 videos going on here. This is not okay.
There are plenty of real world.
There we go. All
There are
right,
plenty of real world.
Slope dude. Slope dude. Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. He says puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative. On the way down the mountain, he
Nice,
says,
negative.
nice, negative.
And now, after the
Nice,
downhill,
negative.
he's in for the hardest part of the ski run.
And now, after the
long,
downhill,
flat
he's
part.
in for the hardest
He
part of the
says,
ski run,
This
the
is
long,
zero
flat
fun.
part. He says,
This is
zero fun.
This is zero
This
fun.
is zero fun.
This is zero
This
fun.
is zero fun.
And as he finishes
This
the flat
is zero
part, he
fun.
doesn't see well ahead, and all
And
of a
as he
sudden,
finishes the flat
he
part,
comes
he
to the
doesn't
edge of
see
a
well
cliff.
ahead,
It's
and all of a
straight
sudden,
down.
he comes to
So
the edge of a
frightened is
cliff.
he
It's
that he
straight
says
down.
the worst curse
So
word
frightened is
possible
he that he
in
says
math
the worst
and in algebra.
curse word possible in
Undefined.
math and in algebra. Undefined.
This has been the Adventure of Slope Dude. Remember always what he
This has
said
been
during
the
his ski
Adventure
trip.
Slope Dude. Remember
Up the
always
hill or
what
up
he
the
said
slope,
during
he
his ski
said
trip.
puff, puff, positive.
Up the hill or up
On
the
his
slope,
downhill
he
run, he said
puff, puff,
nice,
positive.
negative.
On his
On the
downhill
long
run, he
flat
said
part of the course, he
nice,
said
negative.
this is zero fun.
On the long flat part
And
of the
finally,
course,
when
he
he went
said
over the
this is
vertical cliff
zero
and went
fun.
straight down, he yelled the worst
And
curse
finally,
word
when he
of
went
math
over the
and
vertical
algebra.
cliff and went straight down, he yelled the worst
Undefined.
curse word of math and algebra.
The uphill is a slope with a positive
Undefined.
number. The downhill is a slope with a
The
negative
uphill
number.
is a slope with a
The
positive
flat part
number.
is a
The
slope of
downhill
zero.
is a slope with a
And the
negative
straight
number.
up and down
The
or
flat
vertical
part is a slope of
is
zero.
undefined.
And the straight up and down or vertical part
This has been
is
the Adventure of Slope
undefined.
Dude. Thanks for viewing.
This has been the Adventure of Slope Dude.
All right.
Thanks for viewing.
So Slope Dude rules. You can like get shirts and stuff with Slope Dude on them. Mrs. Gick and I are investigating. So finding a slope when you're given a graph, you're going to first count up or down, and then you're going to count left to right. So if you look at this one, we want to start with the point that's on the left, okay? And then we counted down 1, 2, 3, 4. So that's -4. And then over 1, 2, 3, 4, 5 in the positive direction, and that gives you your +5. So here we have a rise of -4 and a run of 5. Okay. For this one, we start at the leftmost point, go up 2, that's a +2. And then we're going to go right 1, 2, 3, which is a +3, which gives us 2/3. Rise over run, up and down over left to right. Okay, here's some examples of finding slope. So I'm going to start at my leftmost point and go to my rightmost point. I'm going to count up 1, 2. Up is in the positive direction. So I'm going to go up 2, and then I'm going to go right 1, 2, 3, 4, 5. So this is a slope m equals 2/5. Slope, we use the letter m. Okay. So let's look at this one. I'm going to start with my leftmost point, and I need to go down. Oops. I need to go down 1, 2. So that's a minus 2 over 1, 2, 3, 4, 5, 6. Minus 2 over positive 6. And I'm hoping some of you guys are seeing that this can be simplified. You should always simplify. So negative 2 divided by 2, negative 1. Positive 6 divided by 2 is 3. So my slope here is negative 1/3. All right, the slope formula. So this is how we find the slope when we're just given 2 points. Okay. So when we're just given 2 points, we're given an x1, y1, and an x2, y2. Okay. Here's x1, y1. Here's x2, y2. You can use any 2 points on the line. You just might have to simplify your fraction. Use the point on the left as x1, y1. And then your formula, you will be using this a lot, is y2 minus y1 over x2 minus x1. And it's really easy to get your x's and y's and 1's and 2's mixed up. So it's a really good idea, 1, to label your points, and 2, to look at your formula every time. Don't just assume you know what goes where, because especially when you're on a test, it's easy to make that mistake. Okay. All right, so let's try one. First of all, let's look at this example. I really liked this example because of all the color coding. So y2 minus y1, right there, x2 minus x1. I highly recommend that when you substitute in negative numbers, you use parentheses. And then we simplify the top, simplify the bottom, negative 19 over 5. And absolutely put these in a calculator if you need to, because it's really easy to make mistakes with negative numbers. All right, let's try this one. So I have x1, y1, x2, y2. I'm going to look at my formula real quick. y2 minus y1. So I have negative 2 minus 0 over 3 minus negative 1. Okay. Show you where all these things came from. My cats are being crazy. Okay, so that's where everything came from. And then up on the top, negative 2 minus 0 is going to give me negative 2. 3 minus negative 1. Hopefully someone is saying that minus a negative is the same as plus a positive, because it is. So that gives me a positive 4. Negative 2 over 4, I can simplify that by dividing by 2. And negative 1 over 2 is my slope. Let's write that down here. M equals negative 1 over 2. All right, let's do another one. Here I'm going to label on the bottom x1, y1, x2, y2. Ooh, lots of negatives. So we're going to do m equals y2 minus y1. See how confusing it can get with all those negatives? Use your parentheses. 1 minus negative 5. Okay, so on the top I have negative 2 minus negative 4. I'm going to rewrite that as negative 2 plus 4 just to help my brain. And then downstairs we have 1 minus negative 5, which is going to be 1 plus 5. So here negative 2 plus 4 gives me a positive 2 over a positive 6. And hopefully you're noticing that we can simplify that because we can divide by 2 to get 1/3. And then we're going to write our final answer. M equals 1/3. Okay, so always simplify a fraction if you can, and put negative numbers in parentheses when you substitute them into the formula. All right, last thing we need to talk about is horizontal and vertical slopes. It's one thing to know that a horizontal slope is 0, but it's another thing to see what it looks like when it comes out when you do the math. And that's why I wanted you guys to have these examples on your paper to show you what happens when we get 0 on the top or 0 on the bottom. So let's look at horizontal line here. I'm going to label my points, x1, y1, x2, y2. So slope equals y2 minus y1 over x2 minus x1. There's my 0 on top. 2 minus negative 3 is the same as plus a positive, which gives me 5. When 0's on top, the answer is 0. Okay. So that is the slope of this horizontal line. This is 0 fun. This is 0 fun. Remember, slope dude? Okay. Let's look at vertical. We already know that when slope dude fell off the cliff, it was undefined. So let's see what that looks like when we do the math. x1, y1, x2, y2. Slope is 1 minus negative 2 and negative 2 minus negative 2. So I'm going to rewrite this. Minus a negative is same as plus a positive. Oops, my brain's going a little faster than my hand. Which equals 3. And then negative 2 minus a negative 2 is negative 2 plus 2, which is going to give me 0 on the bottom. When 0 is on the bottom, that is undefined. That slope is undefined, and that line is a vertical line. Okay, so you guys have assignment on Alex. Oops. It has today's date on it. I would like you to be working at level 1/2 only. Okay, so stay in your assigned seats, and yes, the sub has a seating chart, so don't try to be sneaky. Stay in your assigned seats and whisper voices only. Okay. Tomorrow for a bell ringer, we will go through this real quick and talk about any questions you have before we move on and practice and learn and practice graphing lines. All right, so we'll see you guys tomorrow. Please be good. Please be good.